Okay, guys, we're going to finish up Chapter 8 today. Before we start, I want to make sure you have a few things out. Number one is this roadmap that you see right here. Okay, so have a roadmap. Have your guided notes, have a calculator, and a periodic table out. Okay, so those four things. We're going to go over like probably 6 practice problems by the end. I promise if you pay attention, you're going to know how to do this stuff. So let's get started. Okay, here's an example of the questions that I'm going to ask you today. We're going to use the entire roadmap. So we might start here with grams of a reactant. And I might ask you, how many grams of product will we form? Okay, well, let's map it out so we can kind of get an idea of what we're going to be doing today. You're going to start with the grams of reactant, and you're going to times it by, which bridge do I cross? The bottom bridge. Okay, so we're going to times it by this conversion factor. Then where do I go? Yeah, I can't go across this bridge pointing the wrong way. So we're going to come up here and go across this top bridge. So I need to times it by this conversion factor. Then how do I get down to the question mark here? I got to go to the very bottom bridge because it's pointing that way, so I'll times it by that conversion factor. Okay, this process of taking mass of reactants and figuring out how many grams of product you're going to form, it's called stoichiometry. Okay, very important part of chemistry. Which is pretty cool. You can figure out how many, like before you even do the reaction, you can figure out how many grams of the product you will form. And it's very accurate, it's very precise. So chemistry is a very precise science. So let's figure out how to do that today. Practice problem number 7. Okay, it says in this equation we got 2 moles of sodium plus 1 mole of chlorine goes to 2 moles of sodium chloride. Here's the question. Determine the mass of sodium chloride produced when 1.5 moles of chlorine gas reacts with excess sodium. So let's follow those steps again. Do I have a balanced chemical equation, guys?
Yes, sir.
Yes, we do. So we can go on to the next step. What should I underline in this question?
1.5.
Good, that's what it gives us. 1.5 moles of what? Of chlorine gas. What should we circle? What do we need to go to?
NaCl.
Yeah, the mass of NaCl. Okay, so let's look at the roadmap and figure out where we are and where we need to go. Where are we, guys, if we're at moles of chlorine? That's a reactant. Okay, so I'm at moles of reactant. Here we are. Okay? Where do we need to go if it wants us to find the mass of sodium chloride? Sodium chloride's right here, so it's a reactant or product? That's a product. So I need to go to mass of product. Where do you see that on the roadmap? Remember, the products are on the right side, reactants are on the left side, so we need to come over to this circle. Let's map it out. Where should we go? Top or bottom bridge here?
Bottom. All over there.
Top. Yeah, we need to go across this top bridge, so we're going to times it by that conversion factor. Then what do? Go across the bottom one, right? Okay. Now that we've mapped it out, let's actually do it. Okay. Let's write down what they gave us. 1.5 moles of Cl2. Always put down what they gave you over 1. That helps us align our conversion factors later on. Okay. Now let's just follow the roadmap. It said to times it by mole B over mole A. Well, mole B is the product that we're going to. Mole A is the reactant that we have. But here's how I think of it. If moles of chlorine's on top, where's it got to go? Moles of Cl2's got to come down here to cancel out. What we put on top is where we're going. What substance are we going to? Good, it's sodium chloride. It's got to go on top. That's the product that we're going to. So that's mole B, the product. Sodium chloride has got to go right here. Okay, now where do I get these numbers from?
You gotta find the mole, man.
Yeah, you get it from the balanced chemical equation. We got to get it from this, right?
Man, I don't even know.
How many moles of chlorine do we have, guys? 1. So I'm going to put that right here. How many moles of NaCl do we have from the equation? 2. So that goes right there. Can I stop there? No, because that just gets me to moles of product. If you cancel out your moles of Cl2, now I'm to moles of NaCl. Can't stop there because I needed to go to grams. So let's do one more conversion factor here. It says molar mass on top, 1 mole on the bottom. Well, if we've got moles of NaCl on top, where does it got to go? Moles of NaCl has got to go on bottom. And it said right here to put 1 mole there. What's the molar mass of NaCl? Where do I get that?
NaCl.
Good. If you look at your periodic table, Na, what is it? 23. And what's chlorine? 35. So Na is 23 and Cl is 35. What does that add up to? That's 58 grams, right? So I'm going to put 58 grams of NaCl on top. Okay, now my moles of NaCl cancel out and I'm left with grams of NaCl. Is that what I wanted to find? Yes. Grams of NaCl is what I wanted. It's mass of NaCl, so we're done. It's just a math problem now. So let's times everything on top. 1.5 times 2 times 58. Okay, that's 174. Is that what you guys got? What do we have on bottom? 1 times 1 times 1?
2.
It's just 1, right? Okay, so 174, but can I just circle 174 and be done?
No, you gotta put grams of NaCl.
Grams of NaCl. Grams is my units, and NaCl is the substance that we're measuring. Okay. Pretty easy, right, if we follow those steps?
It was trippy.
Pretty easy.
But
I've got 5 more problems, and I promise if you pay attention, we'll get this stuff. Okay, let's go to practice problem number 8.
I'm just following you.
Okay, this one's a different reaction. It says if 2.5 moles of S8 is reacted with excess CH4, how many grams of H2S will be produced? Okay, you guys tell me what to do on this problem. Where do I start?
Start with moles of reagent. Okay. Start with.
Is it balanced?
Yes.
Is this a balanced chemical equation?
Yes.
Yes, it is. So now what do I do?
Wait.
What do I underline?
Wait, it gives you.
What it gives you. What did it give me?
5 moles of
Good. What are we trying to find?
grams of H2S.
Grams of H2S. Okay? Grams of H2S. So now let's go to the roadmap. Where are we, guys?
Moles of S8.
And S8 is a reactant. So I'm at moles of reactant. Here we are. Where do I want to go?
2 grams.
Grams of a what? It's a product, so I need to come down here again. 2 grams of a product. Okay? Let's do this. So 2.5 moles of S8. Put it over 1. Okay, let's look at the roadmap. How do I get there? Well, I got to take this top bridge across, and we come down here and take the bottom bridge. So let's times it by this first conversion factor. If moles of S8 goes on top, where's it got to go on the next one? Moles of S8's got to go on the bottom. What are we putting on the top? What is mole B? H2S. And how many moles do I have? 4. So H2S goes there. Where do I get these numbers from? That was a 4 because it had 4 moles right there. How many moles of S8 do I have? Just 1. So that a 1 goes there. Okay, now let's cancel out units. What happens to moles of S8? It's gone, right? Can I stop there?
Well, no.
No. We got to go to grams of H2S. So I need it. Now all that did was give me 2 moles of product. I got to go across this bottom bridge again. It says 1 mole goes on bottom, so that's what I'm going to do. 1 mole of what though, guys? H2S. If it's on top, it's got to go on bottom. What are we putting on top? The molar mass. Well, hydrogen is equal to 1, but I've got 2 of them. So that's 2. Sulfur is what? 32. So, and there's just one of them, so that's 32. What is 32 and 2?
34.
34. That's what you guys are saying, 34. So 34 what?
Moles. No. That's atomic grams.
Grams of what?
Or the molar mass.
H2S. It's grams of H2S. Whenever you find molar mass, it's grams of that compound. Okay, my moles are canceled out and I'm left with grams of H2S. Can I stop there?
Yes.
Yes. Throw an equal sign on this thing and now it's just a math problem. Okay, 2.5 times 4 times 34.
It's 34.
Okay, 340 goes on top. What goes on bottom? Yeah, it's just 1. So that's it. What's my unit? Grams. And the substance is H2S. Okay, very good. Hey, pretty easy? I think so. Okay, what I would like to do now is give you a chance to try this one on your own. So if you're watching the video, please try it on your own, get an answer. So hit pause right now and get an answer first. Okay, guys, let's see how you did with this one. Hey. So what I would do first is make sure that this is a balanced chemical equation. Is it, guys?
Yes.
And it is, okay? Then we're going to underline what it gives us. I hope that you did that. We're going to circle grams of iron. That's what it wants us to calculate. Okay, let's write down what they gave us and put it over 1. 15 moles of Fe3O4. Put that over 1. Okay, now what I like to do is go to the roadmap and figure out where we are and where we need to go. Okay, we're starting with moles of Fe3O4. Fe3O4 right here is a what? It's a product. So we're starting right on moles of product. Now let's figure out where we got to go. To grams of iron. Iron is right here. Is that a reactant or a product?
Product. Or reactant.
Reactant. So I need to come down here to grams of reactants. Now let's map it out. I've got to cross this bridge, and then which bridge do I cross next?
The bottom one.
Isn't it the top one?
What? No,
Okay.
you're starting with the product. Oh, you're talking about the second one.
Yeah.
I thought you were talking about the
Okay, so here's my 2 conversion factors that I need to times it by. So let's do that. Hey guys, it's so simple if you just use your roadmap. It tells you what to do. But let me give you something that I always do. This is the biggest hint to these problems. If moles of Fe3O4 is on top, where's it got to go?
bottom.
Okay, and then what's mole? Mole B's got to go on the bottom. Mole A goes on top. What is mole A? The product or the reactant here?
Iron.
The reactant that we're going to is iron. So we're going to put moles of Fe on top. Now, guys, where do I get these numbers from?
The equation.
The balanced chemical equation. So how many moles of Fe3O4 do we have?
1.
1. How many moles of Fe do we have? 3. Okay. Now cancel out the moles of Fe3O4. I'm to moles of iron, which is moles of reactant. So I'm right here right now. I got to do another conversion factor. Okay, it says molar mass on top and 1 mole on the bottom. 1 mole of what goes on the bottom?
Iron.
Iron. It's got to go on the bottom. What's the molar mass of iron? If you look at the periodic table, it's what? Isn't it 56? 56 grams of iron. Okay, now my moles of iron cancel out and I'm left with grams of iron, and that's what I needed to find. So now it's a math problem, right? Okay, so let's do 15 times 3 times 56. Are you guys getting this? 2,520. On the bottom, it's just going to be 1, so I'm going to keep that. What's my units?
Grams of iron.
Good. Grams of Fe. Okay, raise your hand if you got that before I solved it. Good job. Okay. Hey, now let's complicate it a little bit more, right? Okay, let's do one that goes clear across the road map. Let's do one that goes from here all the way to here. We could do that. Okay. So again, we're going to come down across there, go up, down. Okay. So there's my path. Let's do that. Practice problem number 10. You guys have this, okay? It says if 200 grams of sodium chloride is produced, how many grams of sodium must be reacted with excess chlorine? So maybe you work in a chemistry lab, and your boss tells you you need to make 200 grams of sodium chloride. Well, how much sodium do you need to react with chlorine? That's what we're going to figure out in this problem, okay? So, first of all, is this balanced? Yes, it is. What should we underline? Help me out. 200 grams of sodium chloride. What are we circling? How many grams of Na must be reacted? Okay, let's write down what they gave us and put it over 1. 200 grams of sodium chloride. Put it over 1. Now let's go to the road map and figure out what we got to do. Where are we if we're at grams of NaCl?
On the product side.
Good, we're on the product side and we're at grams. So where is grams of a product? It's right down here, isn't it? That's where we're starting. Okay, now let's figure out where we got to go. Grams of sodium is what we circled. Is this a reactant or a product? Reactant, and we got to go to grams. Grams of a reactant. Where do you see that on the road map? Well, it's right here. Okay. So, whoops. I'm going to put a star right here, right? Okay. So that's where we got to go. Let's map it out. The first step, do we take the top or the bottom bridge?
The top bridge.
Top bridge. Okay. That gets us to moles of this one. Now, which bridge do we take? Top or bottom?
We take the bottom.
Bottom bridge. Okay. Now, which bridge do we take?
The top one.
The top bridge, and that should get us to where we want to go, right? So let's circle those conversion factors. I'm going to times it by that first, this one second,
That one third.
and this one third. Okay? Let's do it. Okay, all you have to do is follow the roadmap. It's that easy. The first one says 1 mole over the molar mass. So I'm going to put 1 mole on top. And if grams of NaCl is on top here, where does it got to go?
On the bottom.
Good. We're talking about 1 mole of NaCl, so we need to figure out the molar mass of NaCl. If you look at the periodic table, what is Na?
Na is
Whoops. Isn't it 23?
yeah.
And chlorine, what's its molar mass? 35. What is that? 58. So 58 grams is going to come in right there. Okay, so all we did was convert to moles of product here. Because my grams now cancel out, I'm at moles of NaCl, which is moles of a product. Okay, so now I'm right here. What do I times it by next, guys?
Times it by A over B.
Good. Mole A goes on top, which is the moles of the reactant, and mole B, which is the product, goes on bottom. But here's how I look at it. If moles of NaCl is on top, what's got to go on bottom?
NaCl.
Moles of NaCl. It's got to be the same to get it to cancel out. The substance that we're going to is always going to be on top. What substance are we going to? What's our reactant that we're going to? Na. So I'm going to put moles of Na on top. Now, where do I get these numbers from?
From the balanced chemical equation.
Balanced chemical equation. Very good. How many moles of NaCl do we have? 2. So that goes down here. How many moles of Na do we have?
2.
2. Okay. Now, because that's 2 divided by 2, could I reduce it right now and say it's 1 and 1?
Yeah, let's do that.
Sure. If you want to. I just never do, but if you did, great.
That's a little easy.
Okay. All right, so what that did was get us to moles of reactant, because now my moles of sodium chloride canceled out. I'm to moles of the reactant. Can I stop there?
No.
No. We got one more step.
Molar mass.
Molar mass over 1 mole. So let's do that. If moles of NaCl is on top. We've got to put it on the bottom. And it says to put 1 mole on the bottom. So that's what I'm going to do. What's the molar mass? Oh wait, it's just moles of Na, right? Moles of Na. Moles of Na here, moles of Na down here. What's the molar mass of sodium? It's just sodium.
Well,
23 grams. 23 grams of Na goes on top. Okay. Now, am I done? Am I to grams of sodium? Yes, so throw an equal sign on there and let's see what you get. Okay. Hey, did you guys get this? 79.3. 79.3 what?
grams of Na.
Grams of Na. Who got that?
Wait, no. I have a question.
Okay, just 1 second, Tammy. So,
Yeah, you're good.
I hope that you're seeing the importance of this. If your boss wanted you to make 200 grams of sodium chloride, how many grams of sodium would you need to start your reaction with? 79.3 grams. Isn't that cool? You can figure out how much you need to start with before you even start it, which is very important in chemistry. Okay? All right. Okay, guys. I want you to try this one on your own. Okay? At least try it. Try it. Use all those steps. I promise if you will at least try it, you're going to learn something. Even if you get it wrong, you're going to learn something. Okay, so if you're watching the video, please hit pause right now and try it. Okay, let's see how you guys did. First of all, hopefully you looked at this equation and asked yourself, is it balanced? And is it, guys?
Yeah.
It already is, so we're good there. Now let's underline what they gave us. 23.5 grams of potassium. And hopefully you circled grams of potassium hydroxide. Okay, let's write down what they gave us and put it over 1. Okay, so 23.5 grams of potassium. Now let's go to the roadmap and figure out where we are, where we need to go, and then let's map it out, okay? So I'm starting at grams of potassium. Potassium is right here. Is this a reactant or a product? It's a reactant, so we're going to start with grams of it. So I'm at grams of reactant. Where do you see that on the roadmap? And hopefully you're saying right there, that's grams of a reactant. Okay, now let's see where our destination's got to go. So grams of potassium hydroxide is where we want it to go. Potassium hydroxide is right here. That's a product. So grams of a product is right there. Okay, let's map it out. You got to take the right bridges here. So you got to come up here, go across there, come down, and take the very bottom one. So we got 3 conversion factors. 1, 2, and 3. Okay, so now let's just follow what the roadmap tells us to do. But I always ask myself this question. If grams of potassium is on top, what's got to go on the bottom? It's got to be grams of potassium. The roadmap told me to put 1 mole on top. 1 mole of what, guys? 1 mole of potassium, because that's the substance we're talking about here. Now, look at the periodic table. What's the molar mass of potassium?
39.
39 grams. Okay, so 39 grams of potassium goes on the bottom. What that does is it cancels out grams of potassium, so I'm no longer at mass anymore. Now I'm to moles of the reactants. So now we're here. Let's go across this bridge. It says times by mole B over mole A. If you get confused by the B and the mole A thing, just ask yourself, if moles of potassium's here, where's it got to go? It's got to go on bottom. Well, the substance that we are going to Mole B, which is the product, is potassium hydroxide. So it's going to be moles of KOH. Now, where do I get these numbers from, guys?
The coefficient.
It's the coefficients from the balanced chemical equation. How many moles of potassium did we start with? 2. How many moles of potassium do we make? 2. So if you want to reduce that, could you right now? You could. You could say this is a 1 and this is a 1. Okay? I'm just going to leave it though. Now my moles of potassium's gone, and I'm to moles of potassium hydroxide. So now I'm at moles of product. Am I done? Nope, I've got one more step. So let's just do what the roadmap tells us to do. Put molar mass on top and moles on bottom. If moles of potassium hydroxide is on top, it's got to go on bottom. And the roadmap told me to put 1 mole. Well, now it says molar mass. It's the molar mass of KOH. Well, potassium on the periodic table has a molar mass of 39. Okay? Oxygen is 16, and hydrogen is what, guys? 1. So what do you get for the molar mass? 56. 56 grams of KOH has got to go on top because that's how you measure molar mass. Okay? Now my moles of potassium hydroxide is gone. We can stop because I'm at grams of potassium hydroxide. And now it's just a math problem, right? Did you guys get 33.7? Okay, so I got 33.7, and what are my units? Grams of KOH. Okay, so let's not get lost in the numbers. Let's not get lost in the process. What we're saying here is that if you start this reaction with 23.5 grams of potassium, and you have a whole bunch of water, you're going to make 33.7 grams of KOH. Isn't that pretty cool? You can figure that out? Right down to the tenth of a gram. I mean, it's incredibly precise, and it's very important to chemistry. Again, I just can't emphasize that enough. Okay, guys, I've only got one more practice problem for you. If you can do this one, you can do any of them. Okay? So I'd like you to take the time to try it on your own. If you're watching the video, please hit pause. Try it. Once you have an answer, hit play. All right, guys, let's see how you did. Hopefully you looked here. Is it balanced? And yeah, it's balanced, so we can move on. Underline what they gave you. What does it want us to find in this one? The mass of aluminum. So we circle that one. Okay? So let's start with what they gave us. 325 grams of aluminum oxide, and put it over 1. Okay? Now let's go to the roadmap and figure out where we are, where we want to go. We're starting with grams of aluminum oxide, which is what, guys? Is this a product or a reactant? It's a product. Okay, it's a product. And we're at grams of that. So we're down here. Grams of a product. Where do we want to go? Well, it's the mass of aluminum. Aluminum's right here. Is it a reactant or a product? That's a reactant. And we want to go to mass of it. So mass of reactant is right here. Let's map it out. Okay? I've got to take this top bridge. Then I'm going to take the bottom bridge. Then I'm going to take the top bridge. So right here, we're going to use this conversion factor at first, the second conversion factor, and there's my third. Okay? Let's just do it in that order, and we've got this thing. Okay? If grams of aluminum oxide's on top, it's got to go on the bottom. And it's telling me to put 1 mole on top. 1 mole of what?
Al2O3.
Aluminum oxide. Yeah, good. So let's take a second and figure out the molar mass. This is kind of a large compound here. Aluminum has the molar mass
Of 27.
27. But how many aluminums do I have?
2.
I have 2 of them. Okay? Oxygen has a molar mass of 16, but how many do I have? 3. Okay, so let's figure out what that is. Hey, did you guys get the molar mass of 102?
Yeah.
Okay, good job. 102 grams. Okay, now my grams of aluminum oxide. Hey, are you guys still striking out the units that can be canceled out? Okay. So now I'm to moles of aluminum oxide, so I'm to moles of a product. Now let's times it by this conversion factor. Okay, again, if you ever get confused, if moles of aluminum oxide is on top, it's got to go on bottom to cancel out. Now the mole A that it's talking about is a reactant. That's moles of aluminum. Now help me out, guys. Where do I get these numbers from? Good, it's the molar ratio of the balanced chemical equation. How many moles of aluminum oxide did we have? 2, so that goes there. How many moles of aluminum did we have? 4. Could you reduce that to 2 over 1?
Yeah.
Could. 2 over 1. You could, but I'm not going to. I'm just going to leave it there. So moles of aluminum oxide cancel out. Now I'm to moles of aluminum, which is a reactant. So I'm right here. I've got one more conversion factor. Okay. It's telling me molar mass goes on top and 1 mole goes on the bottom. So I'm going to put 1 mole here. It's 1 mole of what though, guys? Aluminum. What is the molar mass of aluminum? 27 grams. Okay. Now my moles of aluminum cancel out and I'm left with grams of aluminum, which is what it wanted. Throw on an equal sign. Grab a calculator. Guys, are you getting 172?
0.1.
Yeah. Okay, so yeah, 172.06 or 0.1 if I round it to 1 decimal place.
Grams of aluminum.
What units, Tristan?
Grams of aluminum.
Grams of AL. Okay, whatever is here is going to be your final units. Hey, okay guys, please, quiet. Hey, can we do this stuff?
Yeah.
Again, this is called stoichiometry. So important in chemistry that we understand how to do this. My goal is that you will do so many of these problems that you won't need a roadmap. Do you think we can get there?
With the canvas, maybe.
I hope so. I have guys, before we end the video, to give you more practice, and it takes a lot of practice. These take I've done thousands of these problems, and it's just something that you've got to do to get more practice. To help you, I've got a worksheet in your student workbook. It's called Stoichiometry Worksheet. So let's go there. Again, it's called Stoichiometry Worksheet, and I hope that this video helped.